Assalamu alaikum, my dear student. Today we will talk about Assalamu alaikum, my dear student. Today we will talk about the homogeneous differential equation. A differential equation is of the form dy over dx f of xy whole divided by phi of xy if each terms of f of xy and phi of xy having the same degree. So there are working steps. The first step it is let y is equals to vx, then dy over dx is equals to v plus x into dv over dx. It means when you find the derivative u into v case and find the result. Now the second step it is separate the variables. In the third step we will integrate both sides, and then the fourth step it is when we put back the value of v is y over x and simplify them, find the result. So these are the steps, student. So we applying an application. So we write an application and about this homogeneous differential equation. So student, dy over dx which is equals to y of x plus x sine y upon x. So first we write the differential equation. Dy over dx is equals to y over x plus x into sine y upon x. Put y is equals to b of x, then according to method dy over dx which is equals to v plus x into dv upon dx. When we are applying this method, student, it means dy over dx, if you write the name, equation number A implies that dy over dx which is equals to v plus x into dv over dx. It means we will put the value of dy over dx in equation number A on the left hand side, and y over x, it means it is v, because if you find with the help of this condition, so what is v? V is y upon x. So we write here v plus x times of sine v. So it is first step. Now the second step, if we transfer the value of y v, it is positive, it is positive. So if we transfer any one, they should be cancel each other. X into dv over dx, which is equals to x times sine of v, and x cancel each other. Now the remaining term it is dv over dx, which is equals to sine v. Now student, after that separate the variables. After simplifying, separate the variables. Sine v transfer on the left hand side, so it means 1 upon sine, this is called cosec into dv. When we transfer this value, it is 1 upon sine represent here cosec into dv, and dx multiplying by 1, it means it is dx, and applying the sine integral. Now on integrate we get the integral of cosec, student, you know very well, cosec v. It is log 10 v upon 2, which is equals to x plus c. So when we put here, student, what is v? So put v is equals to y upon x in equation number, for example, if we write the name 1, so 1 implies that in equation 1 we get, so log of 10 y upon x whole upon 2, it means which is equals to x plus 2c. In the next step, we will write in this form, so log of 10y upon 2x, x multiplied by 2, so 2x, which is equals to x plus c. So this is our solution, student. Find the result. This is called the solution of the differential equation. Now the next topic it is equations reducible to homogeneous equation. What does it mean? It means, student, the given differential equation, how can we convert it into homogeneous form? It means the given differential equation is in homogeneous form. We will convert it into homogeneous form. So case 1 about this one. So case 1 is equals to if small a upon a, these are the coefficient of x and y, b upon b, if they are equal, the equation of the form dy over dx is equals to ax plus by plus c, ax plus by plus c. So here we let x is equals to small x is equals to capital X plus h, small y is equals to capital Y plus k. This is the method. I will define you the method of equation reducible to homogeneous form. There is small dy over dx, which is equals to d into d capital Y divided by d capital X. After that, choose hk, and it means we will substitute any values of h and k and satisfy this equation, which is equals to 0. Then after that, this equation, this differential equation converted into this form. That means some values are removed. These equations will be removed. So this is called the method. Then we are applying the variable separable method and find the integrate, and then integrate and find the solution of differential equation. So first we consider, student, like application solve dy over dx, x plus 2y minus 3, 2x plus y minus 3. So now I start from this point. First we will consider as what is the differential equation ax plus by plus c whole upon capital AX plus capital by plus c. When we compare both equations, right? So it means the coefficient of a is 1 according to condition. If a upon a is equals to b upon b, what does it mean? The coefficient of x is 1 upon 2, which is equals to 2 upon 1, b upon b. They are not equal. It means they are not equal. So in this case, student, I have a mistake. A upon A plus B upon B. If the differential equation in this form, so we write in this form. I will correct the method. So it means this will be added, both of them. So it means 1 upon 2 plus 2 upon 1. When this form, it should be present in the given differential equation. So now we will start now that let small x is equals to capital X plus h and small y is equals to capital Y plus k. So the given equation reduces to in this form. If we write here dy upon, because small dy upon dx, which is equals to d into capital Y over d into capital X. So we put here dy into dx, it means it is in capital form. What is x? X represent here capital X plus h plus 2 times of capital Y plus k minus 3 whole upon 2 times of x plus h plus y plus k minus 3. So when we simplifying them, it means x plus 2y plus h plus 2k minus 3 multiplying x plus 2y. So it means in the numerator, so this is constant. We separate 2 times of x plus capital Y and 2 times of h plus k minus 3. According to method student, this will be equals to 0 and choose hk. H plus 2k according to method, they are equals to 0 and choose hk. It means when we select h is equals to, let h is equals to 1, k is equals to 1. So it means when we put here, they are satisfying together. They are satisfying. These values are satisfying each equation. 1 plus 2, 2 plus 1. If we put here, so 1 plus 2 minus 3, 3 minus 3 equals to 0. It means 0 is equals to 0. Means this will be removed. So after that, therefore, d into capital Y upon d into capital X, which is equals to x plus 2y, 2x plus y. So it's in the next step, student, put y is equals to d of x, then dy upon dx, then dy upon dx, which is equals to v plus capital X into dv upon dx. So it means if we write the name of equation, for example, 1, so then 1 implies that, so dy over dx, which is equals to this, that means we write here v plus capital X into dv upon d capital X, which is equals to x plus 2v, 2y. It means y is v of x, capital X, v of capital X, and 2 times of x plus v of capital X. If we take common, x 1 plus 2v, x 2 plus v, they cancel each other, student. So v plus x into dv upon dx. In the next step, student, we will shift this value on the right hand side. So x into dv upon dx, which is equals to 1 plus 2y, and taking LCM. 2 plus y is the LCM. 1 plus 2y, 2v minus v multiplied by 2, it means 2v minus plus minus v square. They cancel each other. The answer it is 1 minus v square whole upon 2 plus v x into dv upon dx. So in the next step, student, if we transfer this value on the right hand side, it means separate the variables. So it means dv 2 plus y is in the numerator and 1 minus v square it is in denominator, which is equals to the x upon dx will be changed on the right hand side. So in the next step, 2 plus v upon 1 plus v and into 1 minus v into dv. So in the next step, student, if we separate 2 upon 1 plus v into dv plus v upon 1 minus v into dv, which is equals to dx upon x. 2 is a constant, student. So if we write here in this form, if we divide both of them, student, v divided by 1 minus v, if we multiplying by 1, so it means minus v plus 1, and we integrate, it means change of sign. So 1 plus 1 minus 1 upon 1 minus v. If we solve it, so dv upon 1 plus v integral sign plus the integral sign of dx upon x. Then we integrate 2 times of ln 1 plus v plus dv minus dv upon 1 minus v. It is ln x plus ln c. So in the next step is 2 times of ln 1 plus v minus ln 1 minus v, which is equals to ln x plus ln c. Put back v. V is equals to, student, what is v? We consider here v is equals to y upon x. So we put here y upon x. So the equation it is 2 times of ln 1 plus y upon x plus y upon x minus ln 1 minus y upon x equals to ln c of x. Both are multiplying together. So according to log rule, we write in this form. So if we solve it, is 2 times ln x plus y upon x plus y upon x minus ln x minus y upon x, which is equals to ln c of x, capital X. So this is called your solution of the differential equation. It is first case. Now case 2 is if a upon a, which is equals to b upon b, then h cube will not be infinite. So a upon a, which is b upon equals to b upon b, which is equals to 1 upon m, we say. It means if we find the value of a, taking the reciprocal on both sides, it means a is equals to am, small am, b is equals to small vm. Then dy over dx is equals to, if it will be converted ax plus by plus c and m multiplied by a of x plus c. In the next step, when we consider ax plus by, which is equals to z, it means we substitute this value and replace the value. Then apply the method of variable separable method. So now we consider here the differential equation x plus 2y into dx minus dy, which is equals to dx plus dy. Student, if you multiplying together x dx, or if we write in this form, x plus 2y into dx, and if we take left hand side dx minus sine x plus 2y into dy, or if minus dy, which is equals to dy. So it means if we take common, whole dx is common value in this way. So x plus 2y minus 1 into dx. And if we transfer this value on the right hand side, so x plus 2y into dy plus dy. Or in the next step is, student, if you take the common dy in both terms, so x plus 2y plus 1 into dy, which is equals to this. So it means if we find dy upon dx, which is equals to x plus 2y minus 1 upon x plus 2y plus 1. It means separate the variable, student. If we dy upon dx, it means dx transfer on the right hand side, so dy over dx, and this value will be transferred and divided it in form, is in this form. So in the after that, student, what is a upon a? What is b upon b? It means a, the coefficient of x is small a, we will write here 1, and the coefficient of x is capital A, it is 1, which is equals to the coefficient of y, it is small b, it is 2, and coefficient of y in the denominator capital B, it means both are equal. This condition is satisfied according to given condition. So let we consider ax plus by is equals to z. It means we will suppose this term it should be in z form. So what is dz? If you find the derivative with respect to z, so dz upon dx, which is equals to 1 plus 2 into dy upon dx. So dz is equals to 1 plus 2 into dy upon dx. If you find the dy over dx here, so when we transfer this value on the left hand side, so dy over dx 2 times, which is equals to dz upon dx minus 1. Because when we shift here 1 on the left hand side, it means it will be negative. Or dy over dx, which is equals to 2 multiplying, when we consider on the right hand side, it means it will be divided of both terms. So it means this term will be multiplying by this. So if we write in this form, 1 upon 2 dz is upon dx minus 1 over 2. So this is called dy over dx. So if we put here, student, in this equation, we write the name of equation number A. So we put dy over dx is equals to in this form. So A implies that 1 upon 2 into dz upon dx minus 1 upon 2, which is equals to z minus 1 upon z plus 1. ये equation formed हो जाएगी student. After that, if we simplifying them, 1 upon 2 whole equation multiplying by 2, if whole equation multiplying by 2, it means 2 multiplied by 2, they should cancel each other. So it means dz upon dx minus 1, 2 divided by 2, it means minus 1, which is equals to 2 times of z minus 1 upon z plus 1. If we shift this value on the right hand side, student, so dz upon dx equals to 2 times of z minus 1 upon z plus 1 plus 1. Because minus 1 when we shift on the right hand side, it should be changed. And taking the LCM, 2 times of z minus 2 multiplying each other, then plus 1 multiplied by z plus 1, it means z plus 1. So the answer it is 2 plus 1z, it is 3z, minus 2 plus 1, it means minus 1 upon z plus 1. So this is called dz over dx. Then after that, separate the variables, then we integrate, separate the variables, separate the variables, z plus 1 upon 3z plus 1 into dz, which is equals to dx. If we consider separate the equation 1 upon 3z plus 1 into dz plus z upon 3z plus 1 student into dz. which is equals to dx. Three z minus 1. Sorry, I have a mistake. 3z minus 1. Now, student, if we integrate, because it has z, so if we take common from this equation, so it means 1 upon 3, 3 common in this form, to z minus 1 over 3 into dz plus, and the integral of the derivative of 3z, it is z. So if we divide z into 3z minus 1, that means if we multiplying by 1 upon 3, so 1 upon 3, it means 3 into 1 upon 3, it is z, and minus 1 over 3, they should be cancel each other, and the plus 1 over 3. So it means if we convert it into 1 upon 3 plus upon 3z minus 1 into dz is equals to dx. So student, z is minus 1 over 3. If we integrate minus 1 over, it is 3. We taken the common from 3. So 3 into z minus 1 over 3, it should be 1. So if we integrate 1 upon 3, z minus 1 over 3 upon dz, which is equals to plus 1 upon 3 into dz plus, because if we will consider here 1 upon 9, because again we will take common. So 1 upon 9, 3, if we take common, z minus 1 over 3 into dz is equals to dx. Taking the integral sign on both sides. But when we take common, student, so 1 upon 3 multiplied by 3, it is 1 upon 9. And the integral of ln z minus 1 over 3, 1 upon 3z plus 1 upon 9 of z minus ln z minus 1 over 3 equals to x plus c. On integrate, we get, so it means when we simplifying and put back z, z is equals to 2x plus 3y. So when we put here, both are similar, student. So 1 upon 3 plus 1 upon 9, if we take the LCM, so it means in the next step, when we put here, first we are simplifying these values. So 1 upon 3 plus 1 upon 9, it is 3 3 the 9, 4 upon 9. 4 upon 9 ln z minus 1 over 3 plus 1 upon 3 of z equals to x plus c. Then put back z, put z is equals to 2x plus 3y, I think. We'll check this term. What is z? Z is equals to x plus 2y. So we write here x plus 2y. Z is equals to x plus 2y So 4 upon 9 ln x plus 2y minus 1 over 3 plus 1 upon 3 into x plus 2y equals to x plus c. So this is your solution of the differential equation. I hope, student, you will learn about the lecture. We will consider the homogeneous differential equation, and the other topic it is equation reducible to homogeneous differential equation. There are two cases, case 1 and case 2. We will consider both of them. So thank you very much. Take care. God bless you. Allah.